So today's topic is properties of logarithms. Our objective for today is to condense and expand log expressions using the properties of logs. This will be demonstrated on the exit ticket, the quiz, and then the final. I want to remind everybody that I assigned a quiz on Wednesday, and it is due today by midnight. So make sure you complete that quiz. That's due by the end of today. All right. We're going to go over a couple different properties of logarithms, the product, the quotient, and the power properties. And then we're going to go kind of more in depth, do some practice with each one of those properties, the product, the quotient, and the power property. At the very end, we'll have some you do practice problems that are very similar to the ones we've done, very similar to the ones you'll see on the exit ticket, all that good stuff. Once we're done with all of that, we'll start you guys can start the exit ticket, and then you should have enough time if you are working diligently to complete your homework as well. And so you should have all of your work done. Let's start with the properties in general, going through them. First one is the product property. The product property comes from the fact that we are multiplying two things together inside of my log. And whenever we're multiplying two things together inside of our log, what we can do is break them up into two different logs with a plus sign in between. So if there's ever multiplication inside of here, like this m times this n, I can break it up into two logs with an m in one of the logs and an n in the other log. I can do a very similar thing with the quotient property, but instead of multiplication and addition, it's division and subtraction. So if I ever divide two numbers by each other, like so, I can rewrite it as m minus n, that order. All right? That's about it. Those are the two big ones right there. The last one is the product property. This has been getting a lot of students problems. All we do with our product property is if there's an exponent right here, I take it out to the front. Okay. If it's timesing by n at the front, I can bring it up to the exponent. I can go between the two, depending on what the problem's asking me to do. So those are my three properties. Let's go into it. Let's start with the product property. So again, the product property says that if I multiply two things together inside of my logarithm, I can break it up into two different logarithms. And it also says that I can go the other way. So if I start with two different logarithms with the plus sign in between, I can put them together by multiplying the two things that are inside the logarithm, the 5x and the 3x. So I will get log base 4 of 5x times 3x. I will multiply those together to simplify a little bit and get log base 4 of 15x squared. 5 times 3 is 15. X times x is x squared. That is my answer. Similarly, over here, we can do the same type of thing, but in reverse. So instead of starting with the plus sign in the middle with two separate logs, sometimes they'll ask us to expand the following logarithm by taking the multiplication and breaking it up into two pieces. So instead of xy, it's going to be log x plus log y. And that is it for this one right here. Very simple. Again, if there's a plus sign in between them and I'm asked to combine them, I multiply the two pieces and then simplify a little bit. On the other hand, if there's just a multiplication, it's asking us to expand. I can take that xy right there and I can break it up into x on one, y on the other. Okay. Any questions before I set you loose to work on these two problems right here? Yeah. right, let's try these two right here. Same thing. Try it out. Let's go. Put 2 minutes on the clock. Let me get my clock counter out. You have 2 minutes starting now. Right. So let's go over these problems now. Anybody tell me what my answer for this one is? Good idea. Yeah. Give me 1 second. I've got my insert equation. I need some time. Perfect. Correct. Now what do I do to finish that one off? What did we do above? How do we go from here to here? Perfect. That's it. One other thing I want to mention is that this number right down here is not a 1, but it's an invisible 10. Whenever we don't see that number, this is what's called my common log. We learned about that last class. That's an invisible 10. Right. What about this one over here? Let's work on this one. Turn. Log base 5 of 12xy. Who can tell me the answer for this one? All right, let's try it. That is very close to the right answer. Very close. The only thing is that these numbers are off. The x and y are perfect though. What I'm going to do with the numbers is the same thing I did with my x, y, and actually break that one as well apart as the first part. So it'll be log base 5 of 12 as well, plus log base 5 of x plus log base 5 of y. So I have all three of them that I'm breaking up into. That's that little tricky thing, because I got to think about this. Each one of these are really getting multiplied by the next one. All right. Since all three of them are getting multiplied, I can break them up into each piece. Are there any questions on either of these two problems? Anybody confused about anything? Anything that anybody wants me to go over? Anything at all? All right, I don't see any comments. We're going to move on in a second if I don't see anything else. All right, let's keep moving to the quotient property. The quotient property is very similar to the product property that we saw above, but this time it's division and subtraction, like I said before, instead of multiplication and addition. But it's that same process that we had before. If there's a minus sign between two logs, I can combine them by dividing the two numbers. So I can go 6 divided by 9 to give me 6/9, which then simplifies down to be 2/3. Now, this is a question for everybody. What is this equal to? Let's see if anybody can give me the answers to this that we learned about last class. How to put this into my calculator and find out what this is equal to. Who can tell me what this is equal to? Remember, if you have an answer but you don't want to say it out loud, you can always put it in the chat. And that way, I can always double check that you have the right answer, so you feel safe. Mm-hmm. Ooh, not quite, but close. It should be 0.292. Let me get 29. Let's see how we do that over here. So if I was trying to find this, I would go log of 2/3 divided by log of 4. I get that negative 0.292. Again, all I do is I take the log of my outside number divided by the log of my base number. The log of 2/3 divided by log of 4, which gives me that negative 0.29. Let's move on to this one real quick before we move into our last answer. Log of 6 over x divided by y. This time we're going the other way. We're expanding our form. So we're going from something like this to something like this. Since I have an x over a y, I'm going to break it up into an x minus my y. There. Division turns to subtraction. Then I'm done. Nice and easy. Are there any questions on either of these two problems before I set you loose to work on the next two? All right, I would like everybody to try and work on these two. I'm going to give you about 2 minutes to complete them. Let me know if you have any questions along the way. I'm here to help. We have 2 minutes starting now. All right, so let's go over our answers now. Who thinks they know the answer to this first problem right here? Log 6x minus log 4x. That's perfectly correct. Someone said 0.18 is my answer. So I'm going to put that in below this right here. New equation, approximately 0.1. Let's go through how we got that. So we see that 6x and that 4x. We can combine those with that minus sign in between to make it log space. Make it look nice, I'll go the thing. 6x divided by 4x. Who can tell me what this simplifies down to be? What is 6x divided by 4x equal to? Perfect. That ends up giving me, ooh, someone was close to the right answer. They forgot to cancel out the x's. 3 over 2. Because the 6 and the 4 simplified down, and the x's also cancel out to give me that 3/2. I plug that into my calculator, and then I get 0.18 as my answer. Scroll down a little bit so we have it more on the screen. It's a little easier to see. Are there any questions on B, how we got that answer or anything? Anybody need me to go over it some more? Anything at all? All right, let's go into C then, for this next one. Who can tell me what they got for their answer for this one? Good. Log lower 5/7 minus log base 5 of xy. That's a great first step. There's something else that we can do with this problem actually. So what I can also do is break up this xy pair right here, since it is also technically a multiplication like above. And so what I can do is break this up into log base 5 of 7 minus in parentheses, log base 5 of x plus log base 5 of y. And so that would end up being my answer right there. Now, if you wanted to, you could take it even one step further and rewrite this as the same thing, but with a minus sign before both of these. Like this. Both of these answers would work. So let's change this a little bit. Let's do a little bit of highlight color so we know that this is correct. Put it in green. So either of these two answers would work. I would accept both of these answers as a correct answer. Are there any questions on that? Yeah, I can repeat C. So again, when I break this apart, I'm going to take it piece by piece. So I see that 7 divided by xy, that divided by symbol means that I'm going to break it up into a minus sign. All right. 7 minus xy. And that's because that same rule we had above, the quotient property right here, turns into a minus. Now I can break up this xy pairing into a x and a y with a plus sign in the middle because of my product property from above. We saw that from here. We actually saw almost this exact same problem right up here. And so we can break this out. Now we have to put in parentheses because of the fact that this is actually the negative of it, which makes it slightly different. All right. Now, if we want to, we can kind of distribute that negative to both of these, and we could get it like this. That's my answer. And again, either of these two answers works. You could put it, leave it like this and be correct, or you could leave it like this and be correct. One other thing I want to talk about is that we need to always simplify from left, hope I can type sometime, to right. So if I'm going, this is an aside, this is separate from the problem. This is just a little extra thing that I want to talk about. We always want to simplify left to right. Because if I tried to combine these two first, it would not work. All right. If I tried to go log base 5x minus log base 5y, I would not get the correct answer. So I have to go log base 5 of 7 minus log base 5 of x, and then subtract this one at the end. Okay. Must always go left to right. These two first, then these ones right here. Are there any questions about that? Any questions? Anybody want to hear anything more about it? Anything at all? Any more questions about either of these two as well? I'll give you some time to write this down as well. Don't feel like you need to rush. Just let me know. All right, let's move into our last section right here, the power property. The power property gives a lot of people problems for some reason. I think it's one of the easier ones. It is literally just if there's an n, you move it out front. So if there is an exponent inside my problem, I can move it out front to the front of my equation, turn it into a multiplication. And vice versa, if there's an n in the front of my equation, I can move it as an exponent above the n. Move it out front or move it up to the exponent, flip-flopping it. So like this one right here, I have a number out front right here. That's 1/3. So I'm going to move it up to being an exponent right here. So I get log base 4 of 8 to the 1/3 power. Now what's tricky about this is that you then have to do some simplification. Like you have to simplify 8 to the 1/3 power right here. To do that, we need to rewrite this as a cube root. So I can rewrite this 8 to the 1/3 as the cube root of 8 to the first power. That's going from exponential form to my radical form that we learned last unit. Can anybody tell me what the cube root of 8 to the first power is equal to? Perfect. 2 is my correct answer. The cube root of 8 to the first is the cube root of 8. Which is 2. All right, so we simplify that. We get log base 4 of 2 right there. Now, who can tell me what this right here is equal to? What is log base 4 of 2 equal to? Plug that in that calculator and let me know. Perfect. The correct answer is, I like the fraction bar version, 1/2, which is also the same as 0.5. If you were to plug it into a Desmos calculator, it would probably give you 0.5 as your answer. I would accept that as an answer. I like fractions better, so I'm going to leave mine as a fraction, 1/2. Are there any questions on this one right here about this process of moving it up to the exponent, simplifying, before we move over into this problem right over here? All right, let's do this one here then. The trick to this problem right here is very similar to this one over here, where I have to change this square root of x right here into my exponential form. Now there's some invisible numbers with this square root of x. There's an invisible number out front here, which is a 2, but we don't write. And there's an invisible exponent right here of 1. So I can rewrite this square root of x as x to the 1/2 power. So I can change this equation right here into log base 2 of x to the 1/2 power. And then once I have that 1/2 power, I can move it out front to be 1/2 log base 2 of x. And then I am done with this problem right here. I have simplified as much as I can. Change this radical into an exponent, move the exponent out front. Nice and easy. Are there any questions about either of these two problems before I set you loose to work on these last two problems? All right, try out those last two problems. I'm going to give you a little bit over 2 minutes to complete them. Then we will go over these. You have 2 minutes starting now. All right, that is time. So let's go over these problems now. Who can tell me what my answer for this one should be? I think I got the answer. Riley, do you got any ideas for this one? Try and go through it. So whenever I have this number here, I can move it up to an exponent. So what number should I move to my exponent? Let's look at this up here. Let's clear off my screen. This is our power right here. We're going from this form to this form. So what do I need to move around to make this right here that's here match this right here? The exponent, right? So what am I going to get? Log base 2 is going to be the star. I'm going to tell you that right now. What should my number be right there? Make a guess. Wild guess. Not quite. What other number have we not used from the problem above? Right here. What number have we not used from this right here? Want to get a little closer? Yeah. What is? I'll change it. That's a 5. So what am I going to do with that 5? So what do we do with this n right here? Where did that go to? We're going to multiply. So we already have it multiplied by 5, right? We want to go from here over to here. What did the n go to in this part over here? Perfect. So what would my answer be? Perfect. That easy. It's the correct answer. Log base 2 of x to the 5th power. All right. Any questions on that? Anybody confused on it? Anybody want more of an explanation? Anything at all? All right, let's do this last problem. Who thinks that they can tell me the answer for this last one? This one's a little tricky. Yeah. That is very close to the correct answer. The only reason this is wrong is that this exponent is only for this y right here, instead of the whole x and y. So this isn't quite correct. What I actually need to do is before I do this right here, I actually need to separate it into 2 different pieces using our product rule. So if I use my product rule first, what would I get? Yeah. Mm-hmm. Be y squared, good. And then I'm going to do exactly what you did before with pulling the 2 out front. And so my final answer is going to be log base 7 of x plus 2 log base 7 of y. Exactly right. Very close. You just forgot that little bit of x times y. It means I separate it. All right. That's that trick right there, is that sometimes I have to do other things before I can do the pulling the exponent out. The exponent goes out front only when it's by itself, only when the whole thing's being exponent. Okay. Are there any questions on either of these 2 problems before I set you loose to work on the you do practice problems? All right, let me know if there's any questions that you come up with later on. I'm going to set you free to work on the you do practice down below. There's a couple problems down here that you can work on. Once you're done with them, you can start on that exit ticket, all that good stuff. Let me know if you have any questions. And as always, I'm here to help.